Hello everyone, welcome you all to the atoms and molecules portion. Today we are going to be doing atoms and molecules. It is a grade 9 portion. Before we get into understanding the topic, let me first introduce you to Swiflearn. Swiflearn is interactive classes. It conducts interactive classes. It has a personalized batch of maximum of 6 students. There is a dedicated academic mentor team that works in tracking a student's progress. It also covers the syllabus as per the school's exam schedule, and also we do handle custom requests as well. Some of our key features include detailed progress card. We provide detailed progress card for the students. We also conduct Swiflearn academic test series at regular intervals to track the progress of a student. We also conduct unlimited practice test and subjective test as per the school schedule. Yeah, so before we go ahead, do not forget to like, share, and subscribe to our channel, and also click the bell icon to never miss any update. So now let's start off with atoms and molecules. In our previous live sessions, we already started off with atoms and molecules, and we learned some basics as well. So today's live will basically be a continuation of what we learned previously. Okay, so these are some of the topics that we are going to be learning today. We will be learning what is a molecular mass, what is a formula unit mass. We will be learning what are mole concepts and Avogadro number, and also we will be doing some numericals that are usually asked in your exams. So this is what we are going to be learning today. All the topics are very easy. Okay, often I have seen students finding it a little difficult to understand what is a mole concept and how to find out, or how to solve a numerical based on mole concept or unit mass and molecular masses. So today we will be clearing all the doubts. Okay, if in case you have any doubt, if you have not got any topic that I am teaching you, please do send me a question in the comment section. I will definitely be reading the comment section and I will be answering your questions. Okay, so please be free to answer any to ask any doubts in the comment section, okay, regarding today's topic. Clear? So let us go. Before we go ahead, let us first recall what we learned in our previous classes. Yeah, in our previous live sessions, what did we learn? We learned how to find out ratio of mass, right? We learned when a compound is given to you, how will you find out the mass by ratio of that compound? A quick recollection of what we have learned. I have given you two compounds here. I have given you water and ammonia. Can you try telling me the answer, the ratio of mass of water and the ratio of mass by ammonia in the comment section? Well, we found out that a water molecule has 2 hydrogen atoms and 1 oxygen atom. Yes or no? Yeah. So hydrogen, what is the mass? First, we need to know the mass of hydrogen and the mass of oxygen. So we know that the mass of hydrogen is 1. Okay. And there are 2 hydrogen atoms. So 2 into 1 is equal to 2. Right? So the mass of hydrogen in the compound in a water molecule would be 2, and coming to oxygen, the mass is 16. So the ratio is 2:16. Now when we simplify this, we will get 1:8. Yeah, 2 and 16, when you simplify, you will get 1:8. Now coming to ammonia. Ammonia has 1 nitrogen molecule, 1 nitrogen atom and 3 hydrogen atom. So how do we find out the ratio of mass? First we should know the mass of nitrogen, which is 14. Okay, then we already know the mass of hydrogen, which is 1. So there are 3 hydrogen atoms. So 3 into 1 is 3. So the ratio is 14:3. That is, nitrogen is to 1 nitrogen atom is to 3 hydrogen atom. So you get 14:3. I hope it is clear. Okay, give me a thumbs up in the comment section if it is clear. If you, I will be going very slowly. Don't worry, any doubts you have, ask me in the comment section. Okay, moving ahead. Yeah, so now coming to understanding what is an atomic mass. Basically, one unified atomic mass unit, or we can define atomic mass unit as the weight of 1/12 of the mass of a carbon 12 atom. Okay, basically we are taking carbon 12. See, carbon 12 is an isotope of carbon. Okay, it is a form, or it is an isotope of carbon. You have carbon 14 as well, but we are taking carbon 12, which is an isotope of carbon. Okay, so we are considering carbon 12 to be a standard. Okay, we are considering it to be a standard. So one unified atomic mass unit, we are defining it based on uh, a carbon atom, carbon 12 atom. We are taking carbon 12 atom as a standard. Okay, and one atomic mass unit is the weight of 1/12, that is 1 divided by 12 of the mass of a carbon atom. Now, I know it's not very clear. Let us dig in a little deeper to understand the definition of atomic mass unit. Yeah, so when coming to molecular mass of a substance is the sum of atomic masses of all the atoms in a molecule of a substance. Now, if I say, we already know that atoms combine together to form molecules. Yes or no? We take a lot of atoms, two or more atoms, when they combine together, you get a molecule. Yeah. So now if I want to know the mass of a molecule, how will I find it out? I will take out these atoms that make the molecule. I will find out the mass of each and every atom, and then I'll add up all of them, right? I'll add up all of them to give the molecular mass. For instance, now I say I have a molecule that is made up of three atoms of any element. Okay, three atoms. So now if I want to find out the molecular mass, what will I do? I will just take the mass of these three atoms. Okay, I'll take the mass of these three atoms. I will add them and I will get the total molecular mass. Okay, so let us get back to the definition. Let us get back to understanding the definition of molecular mass once again. The molecular mass of the substance is the sum, okay, it's a sum of the atomic masses of all the atoms in a molecule. You take a molecule, you add all the atoms, the masses of all the atoms, you get the total molecular mass. Now, how do we express it? We express it as atomic mass unit, that is denoted by the small letter U. Okay, that is how you denote atomic or molecular mass. Clear? Moving ahead. Now, let us try to find out the molecular mass of water. Okay, now molecular mass is what? Once again, try to recall. Molecular mass is the sum of all the atomic masses of all the atoms that are present inside the molecule. So you take water. Now water has H2O. That means what? It has how many atoms? It has three atoms. How is that possible? Two hydrogen atom and one oxygen atom. So totally it has three atoms inside it. So one molecule of water has three atoms inside it. How? Two atoms of hydrogen and one atom of oxygen. Okay. So now let us take the mass of each of them. Now hydrogen mass is 1. We express it as U, that is atomic mass unit. Okay. U, like you say grams, you say kilograms. For measuring length, how do you measure length? You measure by centimeters, meters, kilometers, right? Right? Yes or no? Similarly, the unit for atomic mass is or molecular mass is atomic mass unit, which is denoted by the small letter u. Okay, now take the atomic mass of hydrogen. Atomic mass of hydrogen is 1 u. How many hydrogen atoms are there? 2 hydrogen atoms. So 2 into 1, that will give you 2u. Okay, now take out oxygen. What is the mass of oxygen? One oxygen atom is 16u, right? So now we know all the atomic masses of all the 3 atoms. Now let us just add all of them. That is 2 into 1, 1 for hydrogen, into into 1 or plus 16. Okay, so totally you get 18u. Clear? 2 into the atomic mass of hydrogen plus 1 into atomic mass of oxygen. Why that 1 came here? This 1 denotes the number of atoms of oxygen. Okay, here there are 2 hydrogen atoms, so we put 2 here, and here there is only 1 oxygen atom, so we put 1 here. Clear? So totally if you add up all of these atomic masses of all the atoms inside one molecule of a water, we would get 80U. Is that clear? Moving ahead, let us try to do one more question. Okay, calculate the relative molecular masses of HNO3. Now, what is our first step? To count the number of atoms. How many atoms are there? Hydrogen is there, nitrogen is there, and 3 oxygen atoms are there. Yes. Now, what is the mass of hydrogen? One hydrogen atom, it is 1U. Okay. Now, nitrogen, it is 14U. Now, oxygen, it is 16U. Now, just add up all of them. 1 into the atomic mass of hydrogen plus 1 into the atomic mass of nitrogen plus 3 into the atomic mass of oxygen. Yeah. So now if you add all of them, you will get 1 into 1 plus 1 into 14 plus 3 into 16, which totals up to 63U. So the molecular mass of HNO3, of one molecule of HNO3, is 63U. Is that clear? Moving ahead, now coming to the formula unit mass of a substance. Now the formula unit mass of a substance is the sum of the atomic masses of all the atoms in a formula unit of a compound. Let us try to understand what that means. Now usually formula unit mass is calculated for particles of ions. Okay, so now you take sodium chloride. What is the formula of sodium chloride? Sodium and chlorine, that is NaCl, together gives you sodium chloride, which is a compound. Yeah. Now take the formula mass unit of NaCl. Now there is 1 sodium and 1 chlorine atom in it. Yes or no? One molecule of one molecule of NaCl. NaCl is nothing but salt, table salt. Okay, the normal salt that you eat, it's NaCl. Okay, so you take NaCl. It has 1 atom of Na, that is sodium, and it has 1 atom of chlorine. Okay, so 1 into 23. 23 is the mass of sodium, and the mass of chlorine is 35.5. Okay, just add both of them. 23 plus 35.5, you will get a total of 58.5 U. Okay, clear? Is there any doubts till now? So now you have understood how to find out the relative atomic masses of a compound. Now I'm giving you one more question to do. Calculate the formula unit mass of CaCl2. Now it has what? It has calcium and it has 2 atoms of chlorine. Okay, so the atomic mass of calcium is 40 and the atomic mass of chlorine is 35.5. Now there are 2 atoms of chlorine, so you take 2 into 35.5. Yeah, so the total would be 40 plus 71, which is nothing but 111 U. Clear? Is it clear? Okay, now moving ahead, here they have given you a reaction. 2 hydrogen atoms, right? Two hydrogen atoms is combining with one oxygen atom to give you how many molecules of oxygen? Two molecules of oxygen. Okay, or you could say, now if we want to say this reaction, this chemical reaction in terms of their masses, how will you say? 4u of hydrogen. Why 4u? Because totally one hydrogen atom is u. There are two, right? 2 into 2, 4. So totally there are 4u of hydrogen atom. Yes or no? So you take 4u of hydrogen molecules, combine with the mass of oxygen is 16. Okay, so 16 into 2 is 32, right? So 4u of hydrogen molecules combine with 32u of oxygen molecules to give you 36. 32 plus 4 is how much? 36u of water molecules. This is how you say it in the terms of mass. Okay, clear? Moving ahead. Okay, moving ahead. Coming to mole concept. Now, mole concept, usually students find it a little bit difficult to understand, but it is a very, very easy concept. Okay. Now, mole concept, it is more convenient to refer to the quantity of a substance in terms of number of its molecules or atom rather than masses. Yes or no? It's easier. Like we always refer to three hydrogen atoms. We always say like that, right? There are three hydrogen atoms rather than saying there are three u of hydrogen, right? So it's always easier to use how to count the number of atoms rather than to calculate the masses. Okay, so a new term or a new unit was introduced which is called as mole. Okay, now the word mole was introduced by a scientist named as Wilhelm Ostwald. Okay, in the year 1896. Okay, now he derived the term from the Latin word moles. Moles means heap or pile. Okay, in Latin, mole means heap or pile. Okay. Now, the unit mole was accepted in 1967 to provide a simple way of reporting large number or massive of heaps. Now, see, now if see these measurements. Now, for example, now centimeter is measured, length you measure in centimeter. You also measure length in kilometer. Yes or no? Now, if I say I want calculate the distance between say Bangalore to Pune. Okay, if you're calculating the distance of Bangalore to Pune, you wouldn't use centimeters, right? You would use kilometers. Why? Because it would be very difficult, right, to calculate in centimeters. Centimeter is a smaller unit. It will be very difficult to calculate the distance between Bangalore to Pune in terms of centimeter. Yes or no? So that is why we use the term kilometer. Similarly, atoms. It is very difficult to count one atom, two atom, three atom, four atom. That is why together the unit we use the unit mole. Clear? Now, let us see what is one mole. Now, one mole of any species, okay, it can be atoms, it can be molecules, it can be charged species, that is ions, or it can be particles, okay. One mole of any species is the quantity in the number having a mass equal to its atomic or molecular mass in grams. Got confused? Let us try to simplify it a little more. Now, remember initially I told you that we are taking carbon 12 as standard, right? Carbon 12 is an isotope of carbon and we are taking carbon 12 as a standard to measure. Like for example, now I am saying one pair of chocolates. That means what? Two chocolates, right? One pair means what? Two. Number is two. Or if I say 1 dozen of eggs, that means how many eggs are there? 12 eggs, right? So these dozen, pair, all these are standard units. Similarly, as a standard, we are using carbon 12. Okay, 12 gram of carbon 12 we are using. Okay, 12 gram of carbon 12. Now keeping carbon 12 gram. Okay, gram, that is the mass of carbon. Okay, so 12 gram of carbon 12. Keeping that in mind, let us try to understand what is 1 mole. Okay, now the mole is the amount of substances that contains the same number of particles. Now when I refer to particles, I mean whether atoms or ions or molecules or formula units or particle, anything. Okay, as there it is in 12 gram of carbon 12, meaning if I take 12 gram of carbon 12, okay, I'm taking we know that carbon 12 is an isotope. So I take carbon 12 and I take 12 gram of it. So I measure 12 gram of carbon 12 in my hand. Okay, now this is used as a standard. So now if I take hydrogen, like, these weighing balance machines, right? In one you keep, like, if you go to a shop and if you ask, you want say 1 kg of flour or 500 gram of flour, so you seen they keep a 500 gram measuring the unit, they keep it on one balance, and the other they keep on adding the flours to see 500 grams, right? Even fruits are weighed like that, vegetables are weighed like that, yes or no? So similarly we are taking 12 gram of carbon 12 as the standard, and we are adding any other, we measure like hydrogen or oxygen or any other element, we measure based on this 12 gram of carbon 12. Okay, now to understand further, now it is seen that it was noted that 12 gram of carbon 12, okay, is considered to be 1 mole. Okay, and 1 mole of any substance would be 6.022 into 10 raised to 23. Okay, 1 mole. Now if I am telling you 1 mole of hydrogen, that means what? If I'm telling 1 mole of hydrogen, it means 6.022 into 10 raised to 23 atoms of hydrogen. Okay, now if I am telling 1 mole of oxygen, that means it is 6.022 into 10 raised to 23 hydrogen oxygen atoms. Okay, now if I am telling you 1 mole of helium, that means how much atoms it has? It has 6.022 into 10 raised to 23 atoms. Okay, now usually generally you and me do not use 1 mole. Like if I go to a shop and if I say I want 1 mole of apples, okay, it is a standard unit. He can start, the shopkeeper can give me 1 mole of apples, but how many apples will I have with me? 1 mole of apples means how much? 6.022 into 10 raised to 23 apples, okay, which we don't use, right? That means a lot of apples, right? So that is why we use as we say grams or kilograms, we use when we go to shops. Okay, we don't commonly use mole. Okay, now if it is not commonly used, why should we study about it? Because atoms are a lot, right? To measure atoms we need a bigger unit, that is why we say mole. So basically moles are used by scientists to measure the number of atoms or the number of particles or number of ions or molecules in a substance. Clear? So the number of particles that are present in 1 mole of any substance is always fixed, which is 6.022 into 10 raised to 23 particles or ions or molecules or atoms or anything. Okay. Now this 6.022 is into 10 raised to 23 is fixed. It never changes. If I take 1 mole of hydrogen also, it will be having same 6.022 to 10 raised to 23. Now if I take gold, 1 mole of gold also, it will be having 6.022 into 10 raised to 23. Okay, since it is a fixed value, we can refer to it as a constant. Yes or no? We say, right, constant means what? A fixed value. So we have named it as Avogadro's constant or Avogadro's number. Okay, because it is a constant. Clear? Moving ahead, Now Avogadro's constant is 6.022 into 10 raised to 23. By heart that value. Okay, 6.022 into 10 raised to 23. Okay, now if I go to a shop and if I say, give me Avogadro number of chocolates. If I go to a shop and say, give me Avogadro number of chocolates, how many chocolates will the shopkeeper give you? He will give you 6.022 into 10 raised to 23 chocolates in your hand. Understood? Avogadro number is 6.022 into 10 raised to 23, which is also equal to 12 gram of carbon 12. It is equal. Avogadro number is equal to 12 gram of carbon 12. Now, here you need to really understand that. Now, for example, if I am telling I need 1 mole, or I am telling you 1 mole means what? 6.022 into 10 raised to 23 atoms. Okay. Now, if I'm telling you I need 1 mole of hydrogen and I need 1 mole of gold. Okay, these are elements. So I am telling I need 1 mole of what? Hydrogen, and in the other hand I need 1 mole of gold. That means what? In one hand I have 6.022 into 10 raised to 23 atoms of hydrogen. In the other hand I have 6.022 into 10 raised to 23 atoms of gold. Will it weigh the same? Is the mass same? No, because hydrogen mass is different and oxygen mass is gold mass is different. So it will not weigh the same. Okay, the mass is different. Okay, so what is Avogadro number? It is just 6.022 into 10 raised to 23 atoms or ions or anything. It's just a value. It's a fixed value. That is a constant. Okay, now it was seen that when they were measuring all this, it was seen that Avogadro number, that is 6.022 into 10 raised to 23 particles of was equal to 12 gram of carbon 12. Okay, that means 12 gram of carbon 12 has 6.022 into 10 raised to 23 particles or atoms of carbon in it. Clear? Is there any doubt? Please ask me. Also, this Avogadro's constant or the Avogadro number was named after an Italian scientist called as Amedeo Avogadro. Okay, so 1 mole of anything is equal to 6.022 into 10 raised to 23. Clear? Now this of anything matlab what? Of electrons or ions or atoms or molecules or particles, anything. You can measure anything. Clear? Getting the concept? Is the concept clear? Do send me in the chat if the concept is clear. Shall we move ahead? Okay, now the relationship between Avogadro number and the mass. Now I take in one hand 1 mole of carbon atoms. Okay, 1 mole of carbon atoms will be having 6.022 to 10 raised to 23 atoms of carbon in it. This is also equal to 12 grams of carbon atoms in it. Okay, now if I take 1 mole of hydrogen atom, it means what? 6.022 into 10 raised to 23 atoms of hydrogen. But as I said earlier, the mass will differ because the mass of carbon and the mass of hydrogen is completely different, right? So here 1 mole of carbon atoms is having 12 grams of 12 grams of carbon in it, whereas 1 mole of hydrogen is having 1 gram of hydrogen atoms in it. Clear? So we could sum up by saying that 1 mole of any particle, whether it is atoms or molecules or ions, anything is equal to 6.022 into 10 raised to 23 numbers of molecules, and the molecular mass in grams. Okay, we use in grams, which will vary. For different elements, different masses are there, so this would vary. Clear? Now moving ahead. Moving ahead, so if you want to know the number of particles in 4 moles of a substance, what will you do? You will just do 4 into the Avogadro's number. Just do 4 into Avogadro's number. You will get the total number of particles in that. Okay. Now, moving ahead, mass of 1 mole, a quick recollection of what we have learned till now. Okay. Mass of 1 mole of a particular substance is fixed, right? Mass never changes. Different elements will be having different masses. Okay. But with 1 mole of hydrogen atom, 1 mole of hydrogen will have a particular, that is 1 gram of uh, hydrogen atoms, which will be fixed throughout. Okay. Now, mass of 1 mole of a substance is equal to its relative atomic mass or molecular mass in grams. Do not get confused. Okay. Moving ahead, atomic mass of an element gives us the mass of one atom of that element in the atomic mass unit. So we are denoting atomic mass as U, which we learned earlier. Clear? Now, now mass of 1 mole of a substance is called as its molar mass. Right. Now, 1 mole substance. What is the mass of 1 mole? Molar mass. Right. Now, this concept is very easy. Now, if I take the unit of say 1 mole of an atom. Okay, we usually refer it as U. Right. Atomic mass unit is U. Just change it to G, you will get the molar mass. Value will remain the same, just change the unit. So to get the mass of 1 mole of an atom of an element, that is the molar mass, to get the molar mass, we have to take the same numerical value. Do not touch the numerical value, just convert U to G. Okay, to understand it further, see, now atomic mass of hydrogen is 1 U. So now what is the molar mass of hydrogen? It is 1 gram. Okay, just you convert U to G. The numerical value remains the same. Okay, now 1 U of hydrogen has only 1 atom of hydrogen. Okay, now 1 gram of hydrogen has 1 mole atom, that is equal to 6.022 into 10 raised to 23 atoms of hydrogen. Okay, now moving ahead, if you have any doubts, please do send me in the comment section. Okay, moving ahead. Now, to find the gram molecular mass or molecular mass of a molecule, we keep the numerical value the same as the molecular mass, but we simply change its units from U to G. This is what we did earlier. Okay, just change U to G from gram to a molecular mass. Okay, atomic mass we denote as U. If we want to find out the molecular mass, the numerical value remains the same. Just put G. Cut the U and put G. That's all. It becomes molecular mass. Yeah. Chemical formula of what do you want? Yeah. Ask me chemical formula of what are you asking? Now, moving ahead, to find the gram molecule, to find the gram molecular mass or molar mass, as said earlier, you just convert U to G. Now, if I take the molecular mass of water, molecular mass of water is how much? 18 U. How do you find out that? 2 hydrogen atoms, right? 2 into, what is the mass of 1 oxygen atom? 16. So 2 plus 16 is 18 U. If I have to convert it, into molecular mass, or if I have to convert it into molar mass, we will cut the U, we will put it as G. That's all. Clear? Moving ahead, let me see if you can find out this. What is the mass of 0.3 mole of oxygen atom? Try to find out 0.3 mole of oxygen atom. Try to find out. Also, the second question is 0.5 mole of water molecules. Try to find out and send it to me in the comment section. Let us see the answer. Okay, now we know that oxygen atom is how much? 16. The mass of one oxygen atom is 16. So 16 into 0.3. Okay, if you take 16 into 0.3, you will get a total of 4.8 gram. Okay, now mass of 1 mole of water molecule is 18 gram. Okay, so the question is how much is there in 0.5 mole of water. So 0.5 into 18 gram, just multiply both of them, we would get 9 gram, which is the answer. Clear? No, how did you get 70, dear? How did you get 70? See, take the mass of oxygen. Okay, oxygen mass is 16 gram. So 0.3 into 16, you will get 4.8 if you multiply both. And if you take water molecule, it is 0.5. Okay, the question is how much is there in 0.5 mole. So 0.5 into 18. 18, how did we get? It is the mass of the water molecule. Multiply both, we will get 9 gram. Okay, now moving ahead, the next question, a similar question. Try to solve this. What is the mass of 1 mole of nitrogen atom? Try to find out. And also, the B part of the question, how many mass or what is the mass of 4 moles of aluminium atoms? They have given you a hint. The atomic mass of aluminium is 27. What is the atomic mass of nitrogen? It is 14. So now try to find out. Yeah, so 1 mole of nitrogen atom is equal to 1 into mass of nitrogen, which is 14. So 1 into 14, that is 14 gram. Now 4 moles of aluminium atoms, it is 4 into mass of aluminium, 4 into 27 gram, that is 108 gram. Clear? Moving ahead, calculate the number of molecules of sulfur 8 present in 16 gram of solid sulfur. Now this is a little more complex question. Try to find out. See, sulfur, they have given you S8, that is 8 atoms of sulfur. Okay, and 16 grams of solid sulfur is given. How will you find out? Very good, very good. Yes, I'm seeing that you're able to understand and you're able to answer. Very good. Try to answer this question. Let us try to find out how will we solve this question. So 1 mole, first you find out the 1 mole of sulfur. Okay, now 1 mole of sulfur, that is S8. Formula is already given in question. Okay, S8. What is a one mole will be having how many grams? It is 8 into 32. From where did we get 32? It is the total number of mass of sulfur. Okay, sulfur mass is 32. So 8. So 8 atoms of sulfur would have 8 into 32, which is 256 gram. Okay. Now 256 gram of solid sulfur contains how many molecules? 6.022 into 10 raised to 23. Yes or no? That is the Avogadro's number. Okay. Now then you just take 1 gram of solid sulfur will contain 6.022 into 10 raised to 23 divided by 256. 256 is the total in 1 mole of a sulfur. You divide it by the Avogadro's number. That's all. Okay, take the Avogadro's number and divide it with the 1 mole of solid sulfur. You will get a total of 3.76 into 10 raised to 22 molecules. Yes, trying to understand? Give me a thumbs up if you are understanding. Can I go further? Can I go further? Have you all understood this? Yeah, once again, in the question they have asked you to calculate the number of molecules. That is how many molecules will be present in 8 atoms of sulfur. Okay, that is present in 16 gram of solid sulfur. Okay, you take 16 gram of solid sulfur. How many or what is the total number of molecules present in it is the question. So first you find out 1 mole. 1 mole of solid sulfur is 8 into 32. 32 is the mass of sulfur. Okay, so 8 into 32. So totally 1 mole of solid sulfur will be having 256. But the question is, how much is there in 16? Right? So now you find out the total, that is 1 gram. First you find out what is the 1 gram of solid sulfur. Okay, and then for finding out 16 gram, you just multiply it into 60. Clear? So 1 gram of solid sulfur is Avogadro's number divided by 256, and then just multiply it into 16, because in the question they have asked you in 16 gram. If they would have asked you in 10 gram, you would have done 16.022 into 10 raised to 23 divided by 256 into 10 gram. Clear? Understood? Yes, ma'am. Okay, cool. Moving ahead, another question. Try to find out this. It's a similar question. Try to find out the answer, children. They have asked you to calculate the mass in 0.5 mole of nitrogen gas. So first what you will do, you will take out the mass of nitrogen, which is 14 gram, right? N2. So 2 into 14. And then what will you do? You will just multiply it with 0.5. Okay? And the second question is, calculate the mass in 3.011 into 10 raised to 23 number of nitrogen atoms. That means, what is the mass of 3.011 into 23 number of atoms? If I take these many atoms of nitrogen, what is the mass of it? Is a question. How will I solve it? I will take mass, that is molar mass, into number of moles. Okay, molar mass we denote it as capital M. Okay, and number of moles is denoted as small letter n. Okay, now 28 into 0.5. Why we take 28? Because nitrogen mass is 14. So there are N2, that is 28, right? 2 nitrogen atoms. 1 atom is 14. So 2 nitrogen atom will be 28. 14 plus 14 is 28. Yeah. So 28 into 0.5, totally you will get 14 grams. Now coming to the second part of the question, that is in 3.011 into 10 raised to 23 number of nitrogen atoms, what is the mass? How will you calculate this? The number of moles is equal to given number of particles by Avogadro number. You can write down the formula. It is quite important to solve any kind of problems, similar problems. So you take the given number of particles, that is how much is given in the question, that is 3.011 into 10 raised to 23, divided by the Avogadro's number. We already know the Avogadro's number is 6.022 into 10 raised to 23. When you divide, you will get 0.5. How will you get? Just cut these two, right? And then simplify it. You will get 0.5. Clear? Now, they have told you to find out what is the mass of it, right? So one nitrogen atom has 14 as its mass. So in 0.5, what will be the mass? 14 into 0.5 moles, that is 7 gram. Clear? Clear? Just give me a thumbs up. Also ask me if you have any doubts. Please be free to ask me in the comment section. I'll try to solve your doubts. A quick revision of what we learned today. We learned what is a molecular mass, right? Just it is the sum of all the atomic masses of all the atoms present inside a molecule. Then we learned the formula unit mass. Yeah, we learned mole concept. We learned about Avogadro's number, and also we tried solving some numericals. Yes or no? Is there any doubt? Please do ask me any doubt in the comment section. Tell me how many particles how many particles or how many ions or how many atoms or molecules are present in one in the Avogadro number, or tell me what is Avogadro number? What is the value? It is 6.022 into 10 raised to 23. It can be atoms, it can be molecules, it can be ions, it can be particles. Yeah. So now if I go to a shop and if I ask the shopkeeper to give me Avogadro number of oranges, what will he give me? How much oranges will he give me? The shopkeeper will give me 6.022 into 10 raised to 23 numbers of oranges in my hand. Clear? Are we all thorough with the concept of molecular mass, formula unit mass, mole concept, and Avogadro's number? So one mole will always be having 6.022 into 10 raised to 23 atoms in it. Okay, always. So if I go to a shop and if I give me 1 mole of let's say what, yeah, if 1 mole, yes, yeah, ask me question. Correct. Good. Yeah. So coming back now, if I am going to a shopkeeper and if I am asking to give me 1 mole of, let's say, dairy milk, if I'm asking to give me 1 mole of dairy milk, how much dairy milks will he give me? He will give me 6.022 into 10 raised to 23 numbers of dairy milks to me. Okay? Understood the concept? Quickly give me a thumbs up if we can end the live session if you have understood the concept, or else ask me your doubts. I am here to clear your doubts. Okay, so I think we shall wind up today's live session. You can send me any of your doubts in the comment section. I will definitely read to them and try to answer all of them. And if you have any doubts regarding any topics, please do send that topic in the comment section also. We will definitely consider in taking a live session in that topic. Okay, we take classes from grade 3 to 10th grade. So any doubts on any topics, any chapter from your grade 3 to grade 10, whether it's physics, chemistry, biology, maths, social, any subjects, do leave it in the comment section. We would definitely consider taking those in our live session. And also if you want a personalized class, okay, like a one-on-one private class, if you want, you can also contact our website. You can go through our website. Also all the contact details are given down. Our website is swiflearn.com. It is given down. You can just check it. It is www.swiflearn.com. Okay, you can log into that account. There are free trial classes as well. You can try free classes. You can get personalized free classes. Also, if you want to get in touch with us through a telephone, the numbers are given down. You can contact us. We conduct personalized classes, and also we conduct classes batch wise as well, with a batch number of maximum of 6 students. We don't take more than 6 students in one batch, so that we make sure that all the students are understanding the concepts very clearly. That is why we don't take a lot of number of students in one class. Okay, so if you really want to understand any particular topic in your school syllabus, you can contact us. Clear? So this is all for today's class. Do not forget to like, share and subscribe to our channel, and also click the bell icon to never miss any updates. There are a lot of live classes happening in various subjects. So not only your ninth grade, all the grade live classes are happening. So to never miss any update regarding the live classes, do click the bell icon and subscribe to our channel. So this is all for today's class. Thank you very much. I hope the concepts are clear. You have any doubt, do send it in the comment section. Thank you everyone. See you all in the next live session. Thank you.